And welcome, students. We are looking at imaginary numbers today. Exciting. Imaginary numbers. Now, another name for imaginary numbers would be complex numbers. And we are going to define this new set of numbers by stating from the very beginning that I equals the square root of a -1. And then we also will say, and I squared equals -1. All right, so we're going to do a bunch of new things with these two facts. We're going to say this is what I is. So let's look at what else we can do. All right, let's play with a few of these. We see that if we have the square root of a negative number, we can write that as I onto the square root of A. And then we will call that an imaginary number. So let's look at our first example. So I see this negative. Always take care of your negatives underneath the square root first. That's going to be I onto the square root of 25. And then I'm going to say, well, I know what the square root of 25 is. That's just a 5. So this would be 5i. And that would be the answer to A. For B, take out the negative. That's an I onto the square root of 49. And then you will take the square root of 49 if you can, which we can. That then equals a 7i. So look at this guy. Take out my I first, and then I have a 12. Now a 12 will break down. Doesn't break down beautifully, but I do have a 4 in there. And that 4 can come out. The 4 comes out as a 2i. So you'll say this is 2i onto the square root of 3. This will be your answer for that one. Next one, I take out the I. I have 17 left in there, and then he's done because he won't simplify at all. Now that we've learned a little bit about these imaginary numbers, let's do some add, subtract, multiply, and divide. So for adding, we will say that this number here, let me get a different color, this number here and this number here would be the real part. The 3 and the 5 would be the imaginary parts. So we're going to add the real part to the real part and the imaginary part to the imaginary part. So 2 plus 4 is a 6. And then I have 3i and a minus 5i. That's going to be minus 2i. All done. The thing that you need to be careful about whenever you are doing subtraction is you're going to minus the 4, and you're also going to need to minus the -5. So be very careful on that. Those negatives tend to cause issues. So I'm going to do 2 minus 4. That's a -2. 3i minus a -5. That minus is going to make that a plus. So this is going to be 8i. Now if someone asked us, which they might, ask you what's the real part, what's the imaginary part, you would state that -2 is the real part and 8 would be the imaginary part. So very similar to just adding like terms, and basically that is what you're doing. So let's try to multiply. I'm going to just do exactly as I normally would. Everything is going to just come out just very sweet. 2 times 4 is 8. 2 times minus 5, that's minus 10i. 3i times 4, that's plus 12i. And then 3i times a minus 5 would be minus 15i squared. I'm going to add like terms, and I'm going to note that this I squared here, if I look up here, I know that I squared is a -1. That makes this even prettier. So I'm going to have 8, that's going to be plus 2i, and then this -15 times a -1, that's going to be plus 15, and I can now combine it with my 8, so I'm going to combine those like terms, and I'm going to end up with 23 plus 2i, and that would be my answer for that one. I want you to look at this one because we're going to use these to our advantage. Look at this guy here. I have 2 plus 3i, and then I have a 2 minus 3i. Those guys are conjugates of each other. And when I multiply conjugates, something magical always happens. So I'm going to be multiplying this, and I'm going to multiply this, and I want you to be prepared because the magic will happen. 2 times 2, that's a 4 minus 6i plus 6i, there it is, and then minus 9i squared. Look at that. You guys go away. Nice. And then I squared is a negative 1, so that's going to mean that I've got 4 plus 9, and this answer, 13. Whoa. This crazy stuff ends up as a 13. Very exciting. Just a few more problems so we can watch several of these being worked. 2i times 4, that's 8i minus 12i squared. Now I squared is a negative 1, so that means I really have 8i and then plus 12. Now, I don't really like to write it like that because I like for my real part to come first and my imaginary part to come last. So this is the answer that makes me feel good, but this one's right too. All right, so let's look at this next one. Remember that I need to write this out twice and then just multiply. So that's going to be 4 plus 6i plus 6i plus 9i squared. Remembering that I squared is a negative 1, and then that would give me 4 and a minus 9, so that's going to be minus 5 plus 12i to complete that guy. Let's look at this. Oh, I have conjugates here. These are actually called complex conjugates. Fancy name. And what I know is that the magic will happen here. 1 times 1 is 1. Then I'm going to have a minus I, a plus I, and then minus I squared. So then I can see that you guys drop. You're equal to a minus 1. And what I end up with is 1 plus 1, which is 2. So this crazy thing becomes a 2. Ah, that's so nice. Let's do a couple of division problems now. I mean, I look at them and I think, what in the world am I supposed to do? There's not really dividing here because there's nothing really to do. So just look at this as a fraction whose denominator needs to be rationalized because that I right there, he represents square root of negative 1. And if I had a square root in the denominator, I would need to rationalize that. So what I'm going to do is multiply just like I did with square roots. I'm going to multiply by the conjugate, and the magic will happen in the denominator, and then I can make this in just a plain real part and a plain imaginary part. So here we go. Let's play. I got 2 times 2. Well, that's a 4. That's minus 6i minus 2i plus 3i squared, knowing that I squared is a negative 1. I'll simplify that here in just a minute. Let's get this denominator. 4. I've got a minus 6i, a plus 6i, and then a minus 9i squared, remembering that I squared is negative 1. So let's simplify this bad boy. We've got 4 minus 8i. That's going to be a minus 3 all over. You guys are gone. 4 plus 9, that's 13. And this is going to be How about 1 minus 8I over 13? Beautiful answer. It's fine. A lot of times they want you to separate this into the real part and the imaginary part. So what they're looking for is they want you to break this down. They want you to break it down into 1 over 13 minus 8 over 13I. And that way you can see that this is the real part and this is the imaginary part, because that's kind of important to us. All right, let's look at the next one. All right, here we go. I had to move him down. So I need to multiply by the conjugate. You can just think of this as the real part is 0. So all I need to do is just multiply by, I can either multiply by an I or a negative I. It really doesn't matter. I'm just going to multiply by an I. And then see what happens. Because in the denominator, you're going to get I squared, and that's just a -1. So everybody's sign's just going to change. Multiplying here, remember to distribute. 4I plus 2I squared. I squared is a -1. I squared is a -1. Let's see how that simplifies. I'm going to have 4I minus 2 over -1. So this is going to break apart into 2 minus 4I. Because everybody gets that -1, need to distribute that and break it apart. All right, beautiful. The last thing that they might ask you to do with complex numbers is to do I to a particular power. So how you will do that is you'll just look for patterns. So let's look at I to the first, because I sure don't want to figure out what I to the 40th is. So I to the first we're just going to say is I. I to the second we will say is a -1 by definition. I to the third would be like I squared times I to the first. So that's going to be -1 times I. Well, that's minus I. I to the fourth, I could say, would be like I squared times I squared. That's like -1 times -1, because that's what I squared is. So this would be a 1. All right, so I'm going to clean this up a little. All right, so I to the fifth would be like I to the fourth times I. So that would be 1 times I. So this would be an I. So I want you to watch what happens here. Here's where the pattern begins. I to the sixth would be like I to the fifth times I. So that would be like an I, because that's what I to the fifth is, times I. That's I squared. So this would then be -1. I to the seventh would be I to the sixth times I to the first. So -1 times I is just -I. I to the eighth, I could say that's I to the fourth times I to the fourth. That's 1 times 1, which is 1. Let me clean this up a little. So just looking at these patterns, notice any I that's to the power of a multiple of 4, they will be equal to 1. So I can look at this guy right here and I see that I to the 40th, that's a multiple of 4. I know you're a 1. If it's not a multiple of 4, but it is even, then it will be a -1. Notice that 14 is even, but it's not a multiple of 4. I know his answer is -1. Very cool. I look at this 11 and I see that he's odd. His closest multiple of 4 is a 12. He's 1 less than that. So if you look at the multiples of 4 and 1 less than that, your answer is a -I. If you look at the multiples of 4 and 1 less than that, their answer is an I. If you look at the multiple of 4, 1 greater than, the answer is just a plain I, not a -I. So if I were to ask you what is I to the, let's do one more than a multiple of 4. let's say, look at 40, 44 is a multiple, so 45. Then that answer would be, let's see, one more is just a plain I. All right, those are cool little tricks. You won't use that much, but it is a really cool little trick and it's fun to do. So if you have any of those problems in your XYZ, look at the patterns of this right here and you'll be able to figure out what your answer is without having to go all the way through that. Remember, if you have any questions, be sure to email me. I'll be happy to answer those. If you are having trouble with the homework and you need an extension, be sure and email me about that too. Have a wonderful day.